All right, lesson 4. Lesson 4, we're going to switch to a different transformation for today. Today we're going to talk about reflections. And reflections are simply flips. And for this one, we're going to focus mainly on x and y axis reflections and how we write the function notation just like we did for vertical and horizontal shifts. And you can see here, the only thing we have to worry about with reflections is where we put the negative sign. So you can see if I'm reflecting over the x-axis, which is the first one up here, then I'm switching the output or the y values to its opposite. The negative goes outside the parentheses. So when I'm flipping over the x-axis, the y values change to its opposite, and the negative goes outside. The x-axis for a y-axis reflection, it's the complete opposite. For a y-axis reflection, I'm switching the x values or the inputs, and the negative is going inside the parentheses. So with that in mind, let's take a look at our examples here. So this is a graph, and there's various points here. So number 1, graph the function g of x equals negative f of x on the same set of axes as the original graph. Make sure to label. So the key is this is negative f of x. So negative f of x, notice the negative is outside the parentheses. If it's outside the parentheses, this is an x-axis reflection, and I'm switching the y values. So it's an x-axis reflection. It's an x-axis reflection. So I'm switching the y values. Okay. So for each of these points, I'm going to switch all of the y values to their opposites. Meaning I'm going to keep the x values the same, but I'm going to change all the y values to their opposites. So this first one, negative 3, 0, is going to stay at negative 3, 0, because the opposite of 0 is 0. The next one will be negative 1.5, and then I'm going to change negative 4.3 to positive 4.3. The third point will be negative 1, x value stays the same, negative 4, y value goes to its opposite, so positive 4. The next one, we have 0, that stays the same. Negative 1.8 switches to positive 1.8. The next one, 0.6 stays the same, x value. Y value of 0 switches, but the opposite of 0 is 0. Next point, we have 2.6, comma, 3.9 is going to switch to negative 3.9. And then the final point, 4, 0, is going to stay at 4, 0, because the x value stays the same, and the opposite of 0 is 0. So all I'm going to do is I'm now going to graph these points on this graph here, and I'm going to draw the reflection over the x-axis. So I have negative 3, 0. Then I have negative 1.5 and positive 4.3. So that's going to be up here. Okay. Then I have negative 1, positive 4. That's going to be up here. Then I have 0, 1.8 will be about here-ish. Then I have 0.60. That point stayed the same. Then I have 2.6, which is about here. And then negative 3.9. So this point's going to be about here. And then 4, 0. So if I sketch that, it's going to look something like this. Obviously, pardon my poor artistic abilities, but we can see that this is definitely a reflection over the x-axis. And that's all they wanted us to do. So the red graph is the answer to number 1. Number 2, now we're going to graph the function h of x equals f of negative x on the same set of axes. If possible, use a different color. Make sure to label. Okay, so this was, again, the red graph was number 1. So for number 2, we're doing f of negative x, which if we take a look at our lesson notes, if the negative is inside the parentheses, that means it's a y-axis reflection. So because the negative is inside the parentheses, this is going to be a y-axis reflection, which means that I'm switching the x values. So now I'm going to go through all those points, and instead of switching the y values, I'm going to switch the x values instead. So this is a y-axis reflection. So I'm switching x values. Okay. So now I'm going to go through those same original points again, but now I'm going to switch the x values and keep the y values the same. So the first point will be negative 3 switches to positive 3, 0 stays the same. Second point will be negative 1.5 switches to positive 1.5. Again, y value stays the same. Third one will be negative 1 switches to positive 1. Negative 4 stays the same. Fourth one, the opposite of 0 is 0. So this will stay at negative 0, negative 1.8. Fifth one, 0.6 will switch to negative 0.6. And then 0 stays the same. Sixth point, 2.6 will change to negative 2.6. 3.9 stays the same. And then the final point, 4, switches to negative 4. And then 0 stays the same. So now I'm going to graph these points, but it asks to use a different color. So I'm going to use green this time. So we start at 3, 0. So this will be right here. Then we have 1.5. So here's 1.5 and negative 4.3. That's going to be about here. Then we have 1. Whoops, I accidentally erased that. So 1.5 and negative 4.3 is about down here. And then we have 1, negative 4. Then we have 0, negative 1.8. Then we have negative 0.6, comma 0. So that's going to be about there. Then we have negative 2.6 and then 3.9. So that'll be about here. And then we have -4, 0. So if I put all that together, that's going to look something like this. It's going to look something like this. Okay. So the green graph, that is number 2. That is your reflection over the y-axis. So your cool down tonight will be something just like this, where you're doing a sketch. Obviously, you don't have graph paper, so I'm going to ask you to do your best estimate. All right, if you can't get it exact, that's fine. But just to do your best sketch of a graph, just like I did here. I'm not looking for anything too earth-shattering. I just want you to be able to sketch a x-axis and a y-axis reflection.